Mm.
Hello guys. So my name is Karthik and my teammate name is Kirtivasan. So we are gonna discuss about the insights about the working of GPS system with the help of graph tester. So Kirtivasan will carry the introduction.
GPS system is the system software which used to locate the position, navigate the direction, tracking the precise location. It is termed as global positioning system. As an engineer, it is essential to know how the GPS navigation works with the help of graph data structure.
Navigation is about the direction from one place to another place. For example, if we consider to travel from home to railway station, there are n numbers of possible ways to reach the destination. Here, our goal is to find the shortest path and less time consumption to reach the respective place. For the determination of shortest path and less time consumption, there are several methods to find it.
GPS system works with the help of graph data structures and algorithm. In addition to presenting the implementation of GPS and its novel features, we also present experimental results on the performance effects of both static and dynamic graph partitioning schemes. And we describe the compilation of high level domain specific program language to GPS.
So now let's dive into the graph data structure. Graph is a data structure that consists of finite sets of vertices together with a set of unordered pairs of these vertices for an undirected graph or a set of ordered pairs for a directed graph. These pairs are known as edges or lines or arcs for undirected graph and directed edge or directed or arc, directed line for directed graph. An edge can be associated with some edge value such as numerical attribute. These attribute will be based on cost or length or capacity. We can represent the vertices externally also with the help of indices or references.
Graphs are very important in the field of computer science. They are used to model real world systems such as internet where each node represents a router and each edge represents a connection between the routers. The wireframe drawings in computer graphics are another example of graphs.
Done. So let us explore about breadth first search. BFS, I mean breadth first search, is a traversing algorithm where you should start traversing from a selected node and traverse the graph layer wise, thus exploring the neighbor nodes. You must then move towards the next level neighborhood nodes.
As the name BFS suggests, you are required to traverse the graph breadthwise as follows. First, move horizontally and visit all the nodes of the current layer. First, move horizontally and visit all the nodes of the current layer. Move to the next layer. Move to the next layer. Now, Karthik will say about the algorithm of BFS.
So let us consider one example where the starting point of A and the end point is B, as you can see in the image. Right. So first thing is visit neighborhood nodes to A, that is B, E, and F. The vertex to B would become one of A, and since E and F are also at an equal distance as B, hence vertices of both E, F from A could be denoted as 1, A, 2. There is no particular order for node preference, but to make it simple, we begin with B. Since all the neighborhood nodes of A have now been traced, as you can see under, we will mark A as visited and taken the next visited node as the source node, which in the case is node B. Visit all the adjacent nodes to B, which are C, which you can see as 2 of B, and G, 2 of B. Node F is considered the previous step from A, hence it is not visited again. Once all neighborhood nodes from one node are visited, mark them as visited and move to the next step. Third thing is visit all neighboring nodes of node E, which are I and J, and mark E as visited. Visit neighboring nodes of node F, which is K, since all the adjacent nodes have been visited by either B or E. Make node F as visited. Repeat the process until all the nodes on the grid are visited at least once. Once all nodes are visited, you will find that the distance required to reach from A to P is 3 and the shortest route is diagonal. You can see the diagram as well. Keith, you will continue about shortest path algorithm.
First, let us consider one example. If you are going from your house to the baseball stadium, there are in image we can see that there are more possible number of ways to reach the destination. As it is essential to know the method of shortest path algorithm. We use the frequently used shortest path algorithm is Dijitrok's algorithm, which is works on the principle of notations of adjacent vertices and length. Dijitrok's algorithm basically starts at the node that you chose and it analyzes the graph to find the shortest path between that node and all the other nodes in the graph. The algorithm keeps track of the currently known shortest distance from each node to the source node and it updates these values if it finds has a shorter path. Once the algorithm has found the shortest path between the source node and another node, that node is marked as visited and added to the path. The, the process continues until all the nodes in the graph have been added to the path. This way, we have a path that connects the source node to all other nodes, following the shortest path possible to reach each node. For better understanding, consider the graph shown in the image. If we consider 0 as home and 6 as railway station, the main aspect to reach the destination is that the shortest path we have to travel. First, steps to reach the destination will continue by Karthik.
The distance from the source node to itself is 0. For this example, the source node will be node 0, but it can be any node that you choose. The distance from the source node to all other nodes has not been determined yet. So we use the infinity symbol to represent these initially, as you can see and under distance. Now we need to start checking the distance from node 0 to its adjacent nodes. After updating the distances of the adjacent nodes, we need to select the node that is close to the source node based on the current node distances. Mark it as visited, and finally you can add it to the path. Also, we mark it with a red square in the list to represent it that it has been visited, as you can see about diagram. We cross it off from the list of unvisited nodes. So these are the unvisited nodes. Now, we need to analyze the new adjacent nodes to find the shortest path to reach them. We will only analyze the nodes that are adjacent to the nodes that are already part of the shortest path. Node 3 and node 2, you can see under the diagram, are both adjacent to nodes that are already in the path because they are directly connected to the node 1 and node 0 respectively, as you can see below. These are the nodes that we will analyze in the next step. Since we already have the distance from the source node to node 2 written down in our list, we don't need to update the distance this time. We only need to update the distance from the source node to the new adjacent node, which is new node 3. Fine. So distance is 7. Let's see what's the reason behind it. To find the distance from the source node to another node, we add the weights of all the edges that forms the shortest path to reach that node. For node 3, the total distance is 7 because we add the weights of the edges that used to form the path 0 to 3. Node 3 already has a distance in the list that was recorded previously. You can see as 7 in the listed below. This distance was the result of a previous step where we added the weights 5 and 2 of two edges that we need to cross the follow path, and that results 0 to 1 and 1 to 3. But now we have another alternative. See, if we choose to follow the path 0, 2, and 3, we would need to follow two edges 0 to 2 and 2 and 3 with weights 6 and 8 respectively, which you can know as total distance will cover as of 14. Similarly, we are traversing the other arches and nodes and updating the shortest length values. Repeat these steps until the destination point is reached. You can note the diagram as well. So the red line marks the edges that belong to the shortest path. You need to follow these edges to follow the shortest path to reach a given node in the graph starting from 0. For example, if you want to reach node 6 starting from node 0, you just need to follow the red edges and you will be following the shortest path 0, 1, 3, 4, 6 automatically. Yes, conclusion by Kritivasan.
Graphs are used to model connections between objects, people, or entities. For example, in this case study, if you are seeing about GPS system, it is possible under graphs data structure. They have two main elements, nodes and edges. Nodes are nothing but the points, destination and source, and edges are the parts you will cover in the following destination route. Nodes represents objects and edges represents the connection between these objects. Breadth first search is used to navigate to design the destination, and Digitro's algorithm finds the shortest path between a given node, which is called source node, and all other nodes in the graph. This algorithm uses weights of the edges to find the path that minimize the total distance between the source node and all other nodes. Further, we move on the references that International Journal of Advanced Research in Computer and Communication Engineering, which established a source that written by Kudos and Bane, a brief data structure of graph. And another references is a graph processing system by Stanford University written by Salihu and Vedam. Thank you.